Tech in 5.
Dive into Python with a fun game. Learn in just 5 minutes.
Want to create Tetris game in PyGame? Follow me. By the end of this video, you will learn how to do it. Originating from the Soviet Union in 1984, Tetris has since become an iconic and timeless puzzle game. The coding behind Tetris offers a layered set of challenges, from the rotation and precise drop of diverse tetromino shapes to real-time collision detection, ensuring each piece fits snugly. Moreover, maintaining smooth gameplay flow and responding to player inputs instantaneously makes Tetris a prime example of how seemingly simple games can pose intricate coding puzzles. Join me as we navigate and conquer these challenges together. In Tetris, each game piece is known as a tetromino. We represent these tetrominos using the Python enum class, where each tetromino is defined by a 2D matrix. This matrix represents the shape of the tetromino, with 1 indicating a block is present and 0 indicating no block. For instance, the T-shaped tetromino is represented as this. Here, the first list denotes the top row of the T, fully filled with blocks, while the second list places a single block in the center of the next row, creating the characteristic T-shape. These matrices are critical not only for visually representing the pieces, but also for functionality, such as collision detection and rotations in the game code. The tetromino class represents the individual pieces that players manipulate during the game. Each instance of tetromino is initialized with a specific shape, derived from the tetromino shape. The constructor sets up the tetromino's shape and color. It also positions the tetromino horizontally at the center of the game area and at the top vertically. The move method adjusts the tetromino's position on the game board. It changes the x horizontal and y vertical coordinates of the tetromino by the specified amounts, allowing the piece to move left, right, or down. The rotate method modifies the tetromino's orientation. It first calculates a new shape by rotating the current matrix 90 degrees clockwise. It then checks if the rotated shape would fit within the boundaries of the game area without overlapping the edges or other tetrominos. If the rotation is valid, the shape is updated. In our Tetris game, the game area class represents the playing field where tetrominos are placed and manipulated. This class is managing the game state and enforcing its rules. The constructor initializes the game area with a specified width and height, and sets up a grid. Each cell in this grid can hold a state, initially set to empty. The add tetromino method places a tetromino onto the grid. This method iterates through the tetromino's shape, updating the game area grid to reflect the tetromino's blocks and color at the specified position. The isValid move method checks if a proposed move is legal. It checks if moving a tetromino by dx horizontal and dy vertical would place any part of it out of bounds or onto an already occupied cell. If either condition is true, the move is not valid. The clear rows method removes completed rows from the grid. It identifies all rows that are completely filled, removes them, and adds new empty rows at the top of the grid. Lastly, the game over method determines if the game should end. If any part of a newly added tetromino overlaps with existing blocks in the grid, there is an overlap, then the game is over. In the main game loop of our Tetris implementation, we manage all the key functionalities including player inputs, automated game processes, and drawing updates to the display. At the start of each loop iteration, we clear the screen and capture the current time, which helps manage the timing of tetromino drops. We handle keyboard inputs to control tetromino movements and rotations. When the left arrow key is pressed, the game checks if moving the tetromino 1 cell to the left is valid. If it is, the tetromino is moved left. Similarly, when the right arrow key is pressed, the game checks if moving the tetromino 1 cell to the right is valid. If the movement is allowed, the tetromino is moved right. The up arrow key triggers a rotation for the current tetromino. Before rotating, the game checks if the rotated position does not cause any collisions or go out of bounds. Pressing the down arrow key speeds up the tetromino's descent. This is achieved by temporarily reducing the current drop time, which is the interval between automatic downward movements. When the down key is released, current drop time is reset to its normal value to resume the standard speed of downward movement. Every tetromino should move down at regular intervals, which is controlled by comparing current time and drop timer. If the time elapsed since the last downward movement of the tetromino exceeds the current drop time interval, the game proceeds to try to move the tetromino downward. This interval determines how fast tetrominos fall naturally without player intervention. Before moving the tetromino down, the game checks if such a move is valid. This involves ensuring that moving the tetromino one cell downward does not cause it to overlap with other tetrominos already placed on the grid, or to go out of the bottom of the playing area. If the move is valid, the tetromino is moved downward by one cell. If the tetromino cannot move down further, either because it would go out of bounds or because it would collide with other tetrominos, several actions are triggered. At this point, the tetromino is fixed in place on the grid. A new tetromino is then introduced for the player to control, and a sound effect is played to enhance the gameplay experience. After placing a tetromino and before a new one is introduced, the game checks if placing the last tetromino has created a situation where the new tetromino overlaps with others right at its starting position. This condition indicates that there's no more room for new tetrominos, signaling the end of the game. Regardless of whether the tetromino moved down or was fixed in place, the drop timer is reset to the current time, marking the beginning of a new interval for the next automatic movement. The game periodically checks if any rows in the grid are completely filled. These rows are then cleared, reflecting successful gameplay. The clear rows method returns the number of fully filled rows that have been cleared from the grid. If one or more rows are cleared, a sound effect is played to provide immediate auditory feedback to the player. The score is updated to reward the player, with the reward increasing exponentially based on the number of consecutive rows cleared. Additionally, resetting the drop time might adjust the game's pace depending on the player's progress or game settings. Finally, we update the display with the current state of the game. We draw the game and information areas, and the current tetromino, then refresh the screen at a rate of 30 frames per second to ensure smooth gameplay. Now, let's take a look at the info area class, responsible for managing game statistics and the next piece preview. This class plays an important role in gameplay dynamics by handling upcoming tetrominos, scoring, and leveling mechanisms. The info area generates the next tetromino to be played, allowing players to plan their moves in advance. This is achieved through the Generate New Tetromino method, which selects a random tetromino shape. The Pull Tetromino method retrieves the currently previewed tetromino for gameplay and simultaneously generates a new one for the next preview. This ensures a seamless transition and continuous gameplay, as players always have a preview of the next piece and can strategize their placements accordingly. The Update Score method in the Info Area class is vital for tracking and updating player scores and adjusting game difficulty as players advance. This method increments the player's score by the number of points earned through clearing rows. The amount added depends on the rows cleared and any special game actions. After updating the score, the method calculates if the accumulated score has reached a threshold to level up. If the player has advanced to a higher level, the game modifies the drop time to increase the pace of falling tetrominos, making the game more challenging. The drop time decreases as the level increases, with a minimum limit set to ensure playability. Upon leveling up, a level up animation is triggered to provide visual feedback to the player, enhancing the sense of achievement and engagement. The Start Level Up animation method initiates a visual animation when the player levels up. It sets the level up animation flag to true and initializes animation frames to 30. This value determines the duration of the animation, with the animation designed to run across 30 frames. The Continue Level Up method is called in each frame update to decrement the animation frames. This method ensures that the animation progresses over time, decreasing the frame count each game cycle. Once animation frames reaches 0, the animation concludes by setting level up animation to false, signifying the end of the visual effect. In our Tetris game, visual feedback is provided through a series of drawing functions that render the game area, tetrominos, scores, and player achievements. Let's break down these methods to understand how each contributes to the game's interface. The Draw Game Area method draws the game area grid. Each cell of the grid is drawn as a rectangle. If the cell is occupied, it is filled with a color. Otherwise, only the grid line is drawn. The Draw Tetromino method renders the current moving tetromino on the screen, coloring the cells based on the tetromino's color. The Draw Scroll Bar method draws a progress bar that visually represents the player's current score relative to the next level up threshold. It updates dynamically as the player scores points. In our Tetris game, we visually represent each level achieved by the player using circular badges, which add a vibrant and clear indication of progress. These badges are managed through the Draw Badges method. Despite the original badge images being square, we employ a creative masking technique in PyGame to display them as circles. This is done by first creating a badge mask surface, matching the dimensions of our badge image. On this mask, we draw a circle that defines which area of the badge will be visible. We then plit the square badge image onto this mask, rendering only the circular part visible. This method effectively transforms the square image into a circular badge, utilizing PyGame's capabilities for more complex and visually appealing graphics. The Draw Badges function places these badges on the screen in an organized manner, using rows and columns. It calculates the appropriate X and Y coordinates for each badge based on the badge size and spacing, ensuring a tidy and attractive layout. The arrangement parameters, such as badge size and badge spacing, can be adjusted to fit different screen sizes and aesthetic preferences. To further enhance the experience, we introduce animations to the Level Up feature, providing a visual reward for player progress. This animation is controlled within the Info Area class and is brought to life in the Draw Badges method. When a player achieves a new level, the Start Level Up animation method in the Info Area class is activated, setting the Level Up animation flag to true and initializing animation frames to 30. This marks the beginning of an animation sequence that lasts for 30 frames. During the animation, the newest level badge undergoes a blinking effect, appearing and disappearing every few frames. This dynamic visibility is controlled by drawing the badge only when animation frames divided by 5 equals 0. This blinking effect adds an exciting visual element to the level up moments. The Continue Level Up method, which is called within the game loop, decrements the animation frames by 1 with each frame. Once animation frames reaches 0, the animation sequence concludes, and the level up animation is set to false, signaling the end of the animation. Through these detailed techniques and functions, we create a visually engaging and interactive environment that celebrates player achievements and enhances the overall game experience. As we conclude our tutorial on building a Tetris game from scratch, we've explored every aspect of game development. Thank you for joining us, and happy coding!
Stay tuned for more videos on Tech in 5.